So today we have a fairly interesting discussion with respect to the new technology blockbuster participant in the markets that has been around for a long time, but nobody really knew what kind of domineering impact they already have on certain sectors, and no prizes for guessing who that is. I'm going to share a few slides and very quickly get into the game. Okay, so here we go. And of course, you probably know what that is by now. We're talking about NVIDIA, of course. Now, these guys have broken every record there is, both internal as well as external, both their own records in terms of where they are and where they have been and what else they're going to be doing. We are talking about a mind-boggling 265% quarter-on-quarter growth in their billing, in their revenues. And we're talking about a market cap that they crossed actually briefly sometime intraday trading about $2 trillion. And that happened some 10 days ago. So, and in terms of data center market domination, this is unheard of. And for example, let me just put the number in perspective. About 2 years ago, what they did for a whole year in data centers, they've done more than that in 1 quarter this year. So this is the kind of domineering impact we're talking about. So NVIDIA, for those that are not entirely initiated and just heard the name, NVIDIA was actually started off many years ago as a small graphics processing unit, a GPU maker. And this was a peripheral game in the time of the early PC days, when we know that large players like Intel had already touched $100 billion or so in revenue. And here was a small little player that was coming in simply with the express niche objective of enhancing gaming performance. That's all it was. And what a ride from where they were to where they are today, and currently dominating at about 94% plus market share in the data center market. And everything that's going to happen in the next 10 years is going to happen in the data center market because of AI, because of these things. And all of that is going to impact positively to NVIDIA. And in the next few slides, we'll talk about a glimpse, talk quickly, briefly about how that's going to really turn out. Okay, so if you look at the path from where they came, like I said, as a tiny graphics card producer, they moved from there very quickly to virtual reality, to added augmented reality as the technology developed. Then they started doing parallel processing, multiple cores, several dozens of cores per chip, and started increasing the performance. So that's really what the market needed at that time. But nobody would have imagined that that opportunity was going to be super, super large like it is now. And then from there, they quickly went to high-performance architectures where they started creating super high-performance, high-quality, dealing with several billions of bits of data at the same time. From there, it naturally led them to where they are today, which is what we call accelerated computing. And we'll talk about that a little later. But before that, we'll catch up a little bit more about the exciting space they're in and what exactly they're doing to blow your mind away. So one of the biggest areas that NVIDIA has managed to really put an iron grid on, to put a stranglehold on that space is the data center space. Now, and they've become pretty much the gold standard in data centers. There's absolutely nobody to even match them in terms of, forget about market share, in terms of performance, and the space they have created between the nearest competitor and themselves is so huge that it doesn't look like anytime soon there'll be anybody even coming close. So we are talking about 2 years ago, they had a full year revenue of about $15 billion from that segment in the data center segment, and they crossed $18.4 billion in just 1 quarter last year. So you can tell what the delta is in terms of differences with the competition. I'm coming to that slide very soon. Check this, and for this slide, I'm grateful to Eric Flanagan of the Wells Fargo Equity Research. All this data has come from Wells Fargo Equity Research, and I credit them fully for this research as well as data and the graphics. This is public domain information, and I'm sharing the links here openly. This intellectual property does not belong to me or to my company. Now, in terms of estimated data center GPU market share, which is the processors that are going into the data centers, this company has gone on from 87.5% market share to about 94%, expected to go up even further. And let's spend a quick minute and try and understand what was the situation 7-8 years ago. In 2017, for example, there were two players already there, which was not that they were not there. And one was Intel, the other was AMD. And if you look at Intel in 2017, Intel already had a 9.5%, close to 10% market share. And I'll tell you exactly what that number may have meant at that time. And one would have thought that, that data center being the way to go and how important it is to all the big data that was beginning to happen at that time, one would have expected that Intel would have actually pushed the pedal and made more investments and built it up. It's not exactly clear what defocused them or what other area became more important. But without losing focus, NVIDIA simply continued to drive home the leadership position, and they went on to now capturing about 94%. Just check these numbers, and this is a little difficult. I understand it's not easy to read it, but I'm just going to read just a couple of things here. So in 2016, and I'm going back to this slide, just take a look at 2016-2017 timeframe when Intel was already at 9.5% market share. I'm going back to the actual number slide here. In 2016, if you look at these numbers, which are actual because it was historic data, NVIDIA data center GPU chips actually were generating a revenue of $841 million for the whole year for NVIDIA. And believe it or not, at that time, in that year, Intel data center GPU revenue was $314 million. So the delta was about a third. So in other words, Intel was about 29 to 30% of what NVIDIA's revenues were at that time. But then it trailed off to close to zero in 2019 for Intel, and the delta started dropping further. And today it is the pathetic, sub-zero or very small number. So that delta between these two companies who are operating in the same space. And don't forget, the market cap overall and the stock values of Intel was an all-time high in those years. And from then to now, to having trailed off is actually quite pathetic. And I'm not sure how an Intel analyst or someone who's representing Intel would actually define that. But that's really where it is. So this is the kind of delta we're talking about, folks. And if you look at what is the projected value, it looks like between now and next year, NVIDIA will actually cross $46 billion in data center revenue. Data center GPU revenue alone will be about $46 billion. And the overall revenue for the company is projected to be far ahead of north of about $130 billion or so. I don't have the exact data here in the projection on the slide, but that's really where the market is expecting it to go. No wonder at all that NVIDIA has crossed $2 trillion in intraday trading. So that is the kind of a spectacular performance, a player that consistently managed to nail it without really worrying about what others are doing. This is one of those few gems of a company that has really nailed its strategy and performed and executed to the T. So now we'll talk a little bit about what is the big deal about data centers and why data centers and why is it such a big driver of growth. So in the last 10 years or so, we've seen staggering amount of volume of data in terms of social media, in terms of videos, short videos, long form videos on YouTube and on Facebook, as well as on from TikTok. So social media and Instagram, social media has become a primary driver of video information for everyone. So we are talking about pumping the internet with trillions of gigabytes of data that's getting into the market every day, into the network every day. So somebody has got to keep doing this, figuring out what service is being requested, what piece of video is sitting where, what is the speed at which they're connecting, what is the capability of the handset, and both ways, not just delivering it, as well as storing it and producing it on the handset side, and then putting it together and then making it available for driving it. So this kind of volume demands that the 8 billion, 7.9 billion people on the planet have been demanding is actually being served through the net, but by the data centers. So these data centers have become orangutan server farms that are in the cloud, and they're constantly being upgraded to handle this kind of capacity, both from simultaneously managing the requests of the various processors, delivering it to the application. This is exactly the job that NVIDIA is doing, and this is their home turf. And this part of the game they've mastered for the last decade and a half. So I want to spend a minute here and try and explain what exactly is happening on the other new wave that's driving this, which is generative AI. So, and for this, I credit A16Z, the company in the Valley that actually published a report some time ago where they've presented a preliminary understanding of how the generative AI stack looks. So just for information, this generative AI stack diagram, and we'll just quickly go through this and I'll try and explain to you what are the big deal that's going on here in terms of data centers and what the opportunity is. So at the very top, if you can see, these are the users, right? That's users like you and I. So if you and I are either individual users or business users, typically we are using a different set of various apps that we are actually using to access generative AI applications. So there are two ways in which we could be doing this. One is we are using end-user facing B2B apps, which could be without proprietary models such as Jasper, GitHub, or even Copilot. Now, the other ones are where it is an integrated application integrated with a proprietary model, which would be the case of, let's say, Midjourney and so on. So these are the two different types in which we interface and use generative AI apps today. Now, in the first case, where the app is a third-party app and is working without a proprietary model, there you have two possibilities again. One where you have closed source foundation models like ChatGPT 3.54, which is OpenAI. And the other possibility is where you have open source foundation models like Stable Diffusion, in which case you have a third-party model host, which is actually hosting the model, which could be someone like Hugging Face. So that's basically the two types in which we engage with the generative AI, how that is actually being implemented. Now, irrespective of how this actually works out, what is important is what is happening just underneath the layer. Just below this, you will actually see that there is a variety of cloud platforms. And cloud platforms really means, which is the bottom but one layer here. The cloud platforms really means the usual suspects who provide cloud services worldwide. This is Microsoft Azure, GCP from Google, AWS from Amazon, Oracle, or one of these usual large cloud platform providers. The cloud platform providers are in turn being fired or being triggered, being driven by hardcore silicon chipset vendors, which is the very bottom of the plumbing line. And those are the compute platforms, which is again the place where NVIDIA reigns supreme. So that, as you can see, there are GPUs from NVIDIA or TPUs from Google, but keep in mind that that bottom layer is actually the home turf of NVIDIA, and that is the layer from where they're generating all the dollars. Now, as the upper layer, that the cloud platform layer continues to grow because it has to provide for the demands of all those hundreds of applications that people like you and I are demanding every day. As we demand those kinds of outputs and start making those queries, putting those thousands of prompts, the engines underneath are providing the data for it thanks to the cloud servers. And the cloud servers are getting powered by chipsets like NVIDIA and others. This is really the value chain that goes from the bottom of the chipset all the way to the ChatGPT or whatever application we are using on the top. Now, this is the value chain of generative AI. This is exactly similar, if you remember, to the value chain which Intel reigned supreme for more than 2 decades. So what happened to that? So let's quickly look at this comparison, right? So if you notice, this model is actually very similar to what happened in the Wintel world, the Windows and Intel world. So over the Windows operating system, which was 100% property of Microsoft, just above that were all the third-party apps. Many of them were, again, the Office 365, the Office apps, the word processors, the Excels, all of which came from from different parties, and eventually some of them came in-house from Microsoft. And this was the realm of Windows, and the Windows operating system was powered mostly by Intel, and of course the AMD and others came in later. But Intel was actually the engine. So the Windows Intel engine was the unbeatable combination. Of course, one part of it was driven by Mac, which is a different story. But the large part of the global compute space for more than maybe 2.5 decades, and even today to a large extent, it was driven by these guys. And the question that I have is, having done this so well and taken that route all the way to the top, why did Intel not see the same thing happening in this space? And how come Intel did not capitalize or build that model out to execution? This actually shows us that even if you become a world leader and you're $100 billion plus in terms of market cap over multiple decades, and you've seen the next train coming, you could still miss it if your execution is not strong enough, or if for some reason you're defocused. This is the story of Intel. So let's move on now and talk a little bit about something super exciting that I ran into a few days ago. Of course, I didn't attend this, but this was actually Jensen Huang, who's the CEO and founder of NVIDIA. And he was presenting at the Stanford Institute of Economic and Policy Research. And this video is actually available online in YouTube. It happened like 5 or 6 days ago. And it was so impressive. It's a 55-minute odd video interview. I suggest everyone should look at it if you're interested in what's happening in the tech space, especially in generative AI and the future of computing and future of planet Earth. And in that space, there's several things he said which I'll never be able to replicate in terms of sharing with you. But I thought I would take away at least 3 or 4 gems, which I think are things to mull over. So that's really all I'm doing here. I'm just capturing 4 or 5 key points, which I thought I would share with you. And I definitely urge all of you to go back and look at it and soak in, because it is so good in sharing whatever he really believed. Point number 1, he said, and some of you may have already heard this, he said it in different ways, in different contexts, is he says that 5 years from now, there will really be no exclusive programmers. Mostly he says that everyone is going to be a programmer. And if there's any contribution that NVIDIA has done, he says that this entire space of accelerated computing, what they've actually done is they've been able to remove the gap between technology folks and non-technology folks by taking away this programming exclusivity, by making it available for everyone. If you can speak English, you can be a programmer. That's really what he has said. And there's also a comment about, is there a real need for programmers anymore? Because, those kinds of jobs will not really exist. That's a separate discussion. I'll not get into that now. Another thing he said was accelerated computing, according to him, is probably the greatest innovation of the century, the greatest invention of the century. And that there was a little discussion about, was transistor the greatest invention of the previous century? And maybe so. But according to him, for this century, it will be accelerated computing. And he also made a passing remark about the capacity of data centers. He says that it'll go up, and the computing capacity itself will go up by about 1 million times per decade. That's really what has been seen. And he says that in terms of demand, the demand actually will go up about 1 trillion times per decade. And there was this other very strong last words that Jensen shared, which I thought I should say it here. Don't forget, Jensen himself is a Stanford alumni, and he had some amazing things to say about what kind of people come into Stanford and how they actually end up becoming the cream de la cream of the society because of the cohorts, the associated peers, and the general high IQ and high capacity folks that manage to get in and stay in Stanford and get and become super productive and super contributors to the society. Then he said something very powerful. He said, the kind of folks that come into Stanford are great guys. And because they're great guys, and he was addressing them, right? So because you guys are great, and because of that, your expectations of life and your expectations of things will also be great, and nothing to take away from you. That's the right thing to do. But that probably will become a weakness. And he explained that very well. He said, greatness does not come from intelligence. Greatness does not come from intelligence, and I'm unquote and unquote. Greatness does not really come from intelligence. Greatness comes from a space of character. And for character building, what you really need is failure and pain and suffering. If you do not go through suffering and pain, character building will not happen. And when character building does not happen, it becomes hard for you to become great because you will not have that strength to persevere. This is really what he said. And I thought that was a very key takeaway. And he ended this with something that was almost humorous. He said, and I quote, said, "So I wish all of you ample doses of pain and suffering so you may build your character on your way to greatness," unquote. So I thought I would, share that gem with you. I hope you loved it and enjoyed this presentation as much as I had fun making it. Good luck and be in touch. Good day.